Okay, I'm gonna give this a shot. I apologize in advance if it's been kind of going in and out of focus constantly, trying to get a focus, but I'll talk through what I'm doing so that hopefully you can follow along. So we're gonna start with a question like this. Eric is 3 times as old as Sam. 4 years ago, Eric was 4 times as old as Sam was. And the question we are being asked is, how old are both men now? How old are both men now? Okay, so as always, the first thing we want to do is define our variables. So we want to read through this question and we want to listen for what we are being asked. Eric is 3 times as old as Sam. So this means that right now, Eric is 3 times older than Sam is right now. No question there, so we don't have any unknowns yet. 4 years ago, Eric was 4 times as old as Sam was. Again, no question. How old are both men now? So here is our question. How old are both men now? So that's what I want my variables to be. So even if, remember, if you don't know what to do next, the first thing you should always start with is let X represent and let Y represent. Now, what is the question asking us? How old are both men now? So how old is Eric now, currently at this time? How old is Sam now? So let X represent Eric's, and be specific here, his current age. You could not just say Eric's age. It's his current age today, right now. Let Y represent, obviously, Sam's current age. So there, we've got our 2 variables defined. Now we have to come up with our questions, or sorry, our equations. So looking at this first sentence, let's see if there's anything we can glean from it. Eric is 3 times as old as Sam. What that means is that right now, currently, current age, Eric's current age is 3 times more than Sam's current age. So there's our first equation, very simple. Eric's age, which is represented, I almost put an E there for Eric, but Eric's age is 3 times more than Sam's. This is literally saying Eric's age is 3 times Sam's age currently. So here's one of our equations. This is our first equation. Now we want to try and come up with our second equation. 4 years ago, Eric was 4 times as old as Sam was. So this whole second equation, we have to be careful because it's talking about in the past. So I can't just use like an X or a Y because that's their current age. So I have to come up with some sort of an equation that's kind of representing their ages 4 years ago. So let's think about what this is saying. 4 years ago, Eric was. So the was here is going to be an equal sign. Just like up here, Eric currently is. This is an equal sign. Same as this question. 4 years ago, Eric was. That's going to be an equal sign probably. So we need to come up with some expression that represents 4 years ago Eric, or Eric 4 years ago. So let's take Eric's age, his current age. Remember, X represents his current age. Now, how could I make that represent his age 4 years ago? Well, I simply subtract 4, because I know that this number, his age, is in years. So if I just take away 4 from that, you would all agree that this represents his age 4 years ago. So that's this part here. 4 years ago, Eric was. Now, we have to represent this. 4 times as old as Sam was. So you may be tempted to just write, okay, well he was, so equals 4 times Sam. But remember, Y represents Sam's current age. We're not talking about 4 years ago for Eric, but currently Sam. We're talking about 4 years ago for Eric and 4 years ago for Sam. So 4 years ago, Eric's age was 4 times Sam's age 4 years ago, because it wasn't only 4 years ago for Eric, it was 4 years ago for Sam as well. So there's your second equation. What is this equation saying? This is saying Eric's age 4 years ago was equal to Sam's age 4 years ago times 4. And that's exactly what this says. So here are our two equations. X equals 3y and x minus 4 equals 4, and then in brackets y minus 4. So there's our equations, and now we can just use, graphing would obviously not make sense, but we can use substitution or elimination to solve them. So I guess what I would do here is try to get rid of my y or my x, either using substitution or elimination. First thing I'm going to do here is I'm going to distribute this 4 inside these brackets so that I can get a bit neater of an equation. So I'm going to leave this as x minus 4 is equal to, now let's distribute this 4 in here. 4y minus 16. 4 times y is 4y. 4 times negative 4 is negative 16. So here's my new equation. Now I have an equation x equals 3y and x minus 4 equals 4y minus 16. Now, typically, to use elimination, I like to have both my variables on the left side of the equal sign, right? So I want to get this y over here, and I want to get this y over here, and this constant term over here. So you can use either substitution or elimination to solve this. I'll do both for you just on this first example. So that you guys can remember how to do each. Okay, so over here with substitution, I'm going to take my x. Remember, these are my two equations here that I'm dealing with. So over here with substitution, I've already got my x term right here written in terms of y. So x is 3y. So for this equation, x minus 4 equals 4y minus 16. Oh, hopefully I'm still in shot. Yeah. For this equation, I'm just going to take out my x term and put 3y. So this now becomes 3y minus 4 equals 4y minus 16. Okay, so now all I have to do is get my y's on one side of the equation and my constant terms on the other side. So as you guys know, I like, if I can, to have a positive y term. So what I'm going to do is I'm going to take this 3y and I'm going to subtract 3y from this side, and they'll cancel. Subtract 3y over here. So now I have negative 4 is equal to positive 4y minus 3y. So those things will become just a y, and then minus 16. Now I want to get that 16 over to the other side. So I'm going to add 16 to this side, add 16 to this side, and I'll be left with 12 is equal to y. So what this is saying when I have y equals 12 is that Sam's current age is 12 years old. So that means if Sam's current age is 12, I can just reuse this equation, x equals 3y, also known as x equals 3 times 12, to give me Eric's current age of 36. So in theory, this is saying that Sam's current age is 12 years old and Eric's current age is 36 years old. Now, how can I check to make sure that is true? This Sorry, I just want to keep everything in the shot here, so I have to keep standing up to make sure that I'm still within the shot. Let's move this up a bit. So now I'm just going to take my equation up here. Again, this x minus 4 equals 4y minus 16. Uh-oh. And now I'm going to plug in both of my solve values. So I said that x was 36, so I'm going to plug in a 36 here for x. Minus 4 equals 4. Y we said was 12. Minus 16. So in theory, I'm going to get 32 equals 32. So I do this math, 36 minus 4, that's 32. 4 times 12, that's 48. Minus 16, and sure enough, we've solved this correctly. To have a true statement, 32 equals 32. So that's how you could solve it with substitution. So your total final answer here then would be exactly what we had up here. Y equals 12 and x equals 36. So you would just answer with Sam is 12, Eric is currently 36 years old. Now over here with elimination, if I can get it back in about the right spot, like this. So if I wanted to have used elimination, same thing. I'm going to take my x minus 4 equals 4y minus 16. I'm just going to try and get this so that, you know, everything except my constant terms, my non-variable terms, are on one side of the equation. So let's just move this. So I've got x. I'm going to add this 4. So I add a 4 here, and I'm going to subtract this 4y all in one step. So this is x minus 4y equals 16 plus 4, 20. So now I've got this equation here, which is the same equation, I've just rearranged it. And now I'm going to take, can you guys see this? You can't see this. Now I'm going to take this one up here, and I'm also going to move that 3y term over. So x minus 3y equals 0. So these are my two equations now to use elimination with. Now conveniently, they've already got a common x term of 1. So I don't need to multiply either of these equations by anything. I can just subtract them. So I'm going to do that now. So using elimination, this x will cancel out this x. A positive x minus a positive x. That will cancel. I'll have no x term left. Now do your grade 8 math correctly. Negative 4y minus negative 3y. That leaves you with y. Oh, that's not going to work.